There's a place in this universe where no human signal reaches. No radio, no data, no voice from Earth. For 40 straight minutes on April 6, 2286, 4 human beings disappeared behind the moon, completely alone, completely silent, completely cut off from every living soul on this planet. And in that darkness, on the hidden side of a world we have stared at for thousands of years, they saw something that cameras could not catch, something that made trained NASA scientists sitting in mission control in Houston scream out loud, "What did the Artemis II crew capture on the dark side of the moon?" The answer changes everything. Nobody told you the whole story. The headlines said astronauts went to the moon and came back. The news reports called it historic. Politicians gave speeches. There were congratulations and applause and carefully edited highlight reels. But between those polished moments, in the silence, in the darkness, in the 40 minutes when no one on Earth could reach them, something happened that the official announcements did not fully explain. Something that has scientists still processing the data weeks after the mission ended. Something that changes the way we understand not just the moon, but humanity's entire future relationship with deep space. This is that story. To understand what happened on April 6th, 2026, you have to understand what the far side of the moon actually is. Because most people, when they hear the phrase dark side of the moon, think of mystery or metaphor, a Pink Floyd album, a conspiracy theory, something poetic. But here is the real picture. The moon is tidally locked to Earth, meaning it rotates on its own axis at exactly the same rate it orbits our planet. The result is that the same face of the moon, the near side, always faces us. Always. For the entirety of human history, the far side of the moon has been invisible from Earth. Not figuratively, literally invisible. No telescope on Earth has ever seen it directly. No ground-based camera has ever photographed it. The far side is not just distant, it is fundamentally hidden. And for most of human civilization, that was simply accepted as a permanent fact of nature. Then came Artemis II. Launching from Kennedy Space Center in Florida on April 1st, 2026, Artemis II carried 4 astronauts: Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen on a 10-day journey around the moon. The mission had been years in the making, delayed, redesigned, reconsidered, and ultimately launched at a moment when the world desperately needed something to believe in. The spacecraft, an Orion capsule the crew named Integrity, was the first crewed flight of the Space Launch System, NASA's most powerful rocket ever built. But here is what nobody quite prepared the public for. This was not a gentle sightseeing trip. This was, by any objective measure, the most audacious crewed spaceflight attempted in more than half a century. At their farthest point from Earth, the astronauts were more than 252,000 miles away, breaking the Apollo 13 record for the greatest distance any humans have ever traveled from our planet. Think about what that means. Since 1972, no human being had been farther than low Earth orbit. The International Space Station sits roughly 250 miles above the surface. These 4 people traveled 252,000 miles. They did not just leave the neighborhood. They left the entire city, the entire region, and traveled somewhere no human had gone in over 50 years. And then they went around the back. As Integrity passed behind the moon, Earth vanished from the spacecraft's view for roughly 40 minutes, creating a communications blackout and casting the crew in an eclipse-like darkness. That is the detail that doesn't fully register when you read it quickly. For 40 minutes, these 4 human beings had no contact with Earth. No mission control, no voice from Houston, no telemetry uplink. Nothing. They were behind a world made of rock and dust and ancient craters, 252,000 miles from the nearest other human being, and they were completely, totally alone. Commander Victor Glover later admitted quietly that when communication cut out, he said a quick prayer. Then he got back to work. That word, alone, does not capture it. There is no word in any language that fully captures what 40 minutes of absolute cosmic isolation feels like. These astronauts knew, intellectually, that mission control was monitoring their projected trajectory. They knew the physics would bring them back around. But in that moment, in that silence, surrounded by the scarred and ancient surface of the moon's hidden face, they were operating entirely on their own. And what they chose to do in those 40 minutes, what they saw, what they captured, what they reported, is what makes this mission genuinely extraordinary. They monitored color, brightness, and texture differences across the terrain, observed an Earthset and Earthrise, and captured solar eclipse views of the sun's corona. But the most electrifying discovery was not the photographs. It was what their eyes caught that no camera could. Artemis II astronauts reported seeing a handful of bright, fleeting flashes of light on the lunar surface, leaving mission scientists on Earth buzzing with excitement. These were not glitches. These were not reflections from the spacecraft. These flickers of light occur when meteoroids strike the lunar surface and vaporize upon impact. In an instant, a piece of space rock, traveling at tens of thousands of miles per hour, collides with the airless surface of the moon, And for one brief, brilliant moment, there is light. A flash. A signature of cosmic violence written in photons. And here is where it gets genuinely remarkable. These observations were made with the unaided eye. It's extremely difficult to capture impact flashes with a camera, which is one of the benefits of sending trained crew to observe the moon, said Kelsey Young, NASA's Artemis II lunar science lead. Read that again. Cameras, the sophisticated, calibrated, purpose-built scientific instruments, could not reliably catch these events, but 4 human eyes, trained through years of astronaut preparation, spotted them in real time. This is not a minor footnote. This is one of the most compelling arguments for human spaceflight that has been made in decades. There are things the human eye and human brain can perceive that no automated system can replicate. The Artemis II crew proved that in the darkness behind the moon. Commander Reed Wiseman confirmed the sightings, describing how there was a little bit of giddiness among the crew when the impacts were observed. When NASA scientists back on Earth heard the reports, the reaction was immediate and visceral. There were audible screams of delight in the control room, not polite applause, not measured professional satisfaction. Screams of delight, because scientists who have spent careers studying the moon suddenly had something they had never had before. First-hand, eyewitness data from the far side, the hemisphere that no Earth-based observer can ever see. But why does this matter beyond the thrill of the moment? The answer connects directly to everything humanity wants to do on the moon in the coming decades. The scientific community recognizes these observations as crucial data for understanding lunar geology, mitigating risks for future moon bases, and charting humanity's return to the moon. Here is the core problem. NASA is planning to build a permanent lunar outpost near the moon's south pole. The Artemis Base Camp. This is not science fiction. This is a project with engineering specifications, timelines, and budget allocations. But to build something that lasts on the moon, you have to understand every single threat that structure will face. The moon's heavily cratered surface is no stranger to impacts, and space rocks slam into the moon at tens of thousands of miles per hour, with no atmosphere to slow them, making larger impacts a genuine concern for critical infrastructure and crew safety. According to a 2025 study led by Daniel Yahalomi of MIT, to design for longevity, engineers must account for the myriad environmental hazards a long-duration outpost will face. Among them radiation, extreme thermal cycling, regolith dynamics, seismic shaking, dust, and impacts. Every single flash the Artemis II crew witnessed is a data point. Every impact location, every estimated size, every timing signature feeds into models that will determine how thick the walls of the Artemis base camp need to be, how deep the shelters must go, how much shielding an astronaut's suit requires during an EVA on the lunar surface. This is not abstract science. This is engineering intelligence that determines whether future astronauts live or die. Benjamin Fernando of the Department of Earth and Planetary Sciences at Johns Hopkins University explained that coordinated impact flash observations, seen both from Earth and from lunar flyby or orbit, allow more detailed information to be gathered about the timing, location, and dynamics of flashes than is possible from either method alone. In plain terms, the Artemis II crew did not just see something pretty. They provided a category of data that cannot be generated any other way. The far side of the moon is permanently invisible from Earth. No ground telescope can monitor it. No satellite in Earth orbit can observe it. Only a spacecraft near the moon itself. And the human eyes aboard it could gather this information. And they did. Now, let us talk about what else they captured. Because the impact flashes, as significant as they are, represent only one dimension of what the Artemis II crew brought back from the far side. The first flyby images of the moon captured by NASA's Artemis II astronauts during their historic test flight reveal regions of the moon's far side that no human has seen, as well as a rare in-space solar eclipse. Think about the scale of that statement. No human has ever seen these regions of the moon, not the Apollo astronauts, not Soviet cosmonauts, not the international crews of the space station. These specific craters, these specific geological formations, these specific planes of ancient impact ejecta, they have existed for billions of years. And for the first time in all of human history, human eyes looked at them directly and human hands photographed them. Visible in its entirety for the first time is the Mare Orientale, a ringed 600-mile-wide crater created during a lava eruption billions of years ago that straddles the far side of the moon and the side visible from Earth. 600 miles wide. To put that in perspective, that is roughly the distance from New York City to Chicago. This is not a crater. It is a scar the size of a region punched into the lunar crust by an impact so catastrophic it liquefied the surface and sent molten rock spraying across hundreds of miles. And the Artemis II crew flew over it, photographed it up close, and transmitted those images back to Earth for scientists who had only ever studied it through robotic orbiters. A close-up view taken by the Artemis II crew captured Vavilov crater on the rim of the older and larger Hertzsprung Basin. photographed with a handheld camera at a focal length of 400 milliliters as the crew flew around the far side of the moon. A handheld camera, 252,000 miles from Earth, on the far side of the moon. These details matter because they remind you that the technology in this mission is a marriage of the extraordinary and the surprisingly intimate, the most powerful rocket ever built, carrying 4 people with camera lenses and glasses and a playlist of wake-up songs, doing science that will define the next century of human exploration. And then the eclipse happened. As the crew passed behind the moon during their flyby, Earth vanished from the spacecraft's view, and the crew experienced a total solar eclipse as the moon's disk completely blocked the sun. This is not a solar eclipse as you have ever experienced one from Earth's surface. From Earth, during a total solar eclipse, you get perhaps 2 minutes of totality if you are precisely positioned along a narrow path. From behind the moon, the geometry is different. The lunar disk is close enough and large enough from the crew's perspective to block the sun entirely. From the crew's perspective, the moon appeared large enough to completely block the sun, creating nearly 54 minutes of totality, extending the view far beyond what is possible from Earth. 54 minutes. The longest total solar eclipse ever observed from Earth lasts roughly 7 minutes. These 4 astronauts experienced nearly an hour. And what they saw during those 54 minutes has scientists in multiple fields of solar physics simultaneously excited and puzzled. One astronaut described the scene: "The sun has gone behind the moon. The corona is still visible, and it's bright and creates a halo almost around the entire moon. The Earth is so bright out there, and the moon is just hanging in front of us." Ah! The corona, the sun's outermost atmosphere, glowed around the edges of the lunar disk. Stars appeared that are normally invisible when the sun is present. The crew reported being able to see Mars, Venus, and Saturn alongside the stars during the eclipse. And then something else appeared in the images that has the scientific community actively investigating. A glowing halo was visible around the dark lunar disk, and the science community is investigating whether this effect is due to the corona, zodiacal light, or a combination of the two. Zodiacal light is sunlight scattered by dust distributed through the inner solar system. It is faint, diffuse, and almost never photographed from the moon's vicinity during an eclipse. If what the Artemis II crew captured is indeed a combined corona-zodiacal signature, it opens an entirely new window on solar physics that ground-based observations simply cannot replicate. Victor Glover, speaking from behind the moon during the eclipse, expressed something that transcended science reporting and entered the register of pure human experience. "I know this observation won't be of any scientific value," he said, "but I'm really glad we launched on April 1st. Because humans probably have not evolved to see what we're seeing. It is truly hard to describe. It is amazing. Humans probably have not evolved to see what we're seeing." Let that sentence sit for a moment. Here's a pilot with military training and graduate degrees and years of preparation for this mission. A man selected from thousands of candidates precisely because of his extraordinary capability for observation and analysis. And he is saying that the human nervous system was not built for this. The brain cannot fully process it. The experience is too large, too foreign, too far outside the envelope of everything our species evolved to understand. And yet, there he was, in the middle of it, trying to describe it to Houston. Christina Koch radioed back as the communications blackout ended. "It is so great to hear from Earth again." 6 words. But hear what is embedded in them. The relief, the depth of the isolation they had just experienced. 40 minutes of absolute cosmic silence, and then a voice. The sound of Earth, 252,000 miles away, suddenly reconnected. She did not say it dramatically. She said it the way a person says something true. Now step back from the personal and look at the scientific architecture of what this mission delivered. NASA released 12,217 raw, unedited Artemis II images via its Gateway to Astronaut Photography, the largest crewed lunar photo archive since the Apollo era, shot with Nikon D5, Nikon Z9, and iPhone 17 cameras, covering everything from Earth sets and lunar close-ups to solar eclipse views and candid crew moments. 12,000 images, unedited, available to the public, to researchers, to citizen scientists, to anyone with an internet connection who wants to look at the far side of the moon through the eyes of the people who were there. Cosmic photographer Andrew McCarthy worked with Mission Commander Wiseman before launch, teaching him how to capture raw photographs that could be processed to reveal the moon's hidden colors. Color enhancement reveals iron oxide in red tones and titanium-rich basalt in blues, transforming what appears to be a gray, dusty surface into something that looks, under analysis, like a geological gold mine. The moon that most people imagine, gray, barren, dead, is not the moon that scientists see in these images. It is layered with mineral signatures, ancient volcanic plains, impact-shock terrain, and chemical gradients that tell a 4 billion-year story of planetary formation, catastrophe, and slow geological change. The crew also surveyed potential landing zones for future missions, including the mysterious Reiner Gamma Formation, a bright lunar swirl associated with a localized magnetic anomaly, and the edge of the massive South Pole Aitken Basin, one of the Moon's largest impact craters. Reiner Gamma is one of the most scientifically puzzling features on the entire Moon. It appears as a bright, swirling pattern on the surface. But unlike the Moon's other bright features, it is not elevated terrain or fresh ejecta. It is associated with a localized magnetic anomaly, a region where the Moon, which has no global magnetic field, somehow generates a local one. Scientists do not fully understand why it exists. The Artemis II crew flew over it and captured imagery that will fuel years of analysis. And all of this, every image, every observation, every reported flash of light in the darkness, feeds directly into the next chapter, which is already in motion. NASA continues to target early 2020 for the first Artemis lunar landing, a mission designated Artemis IV, in which crew will transfer from the Orion capsule to a commercial lunar lander for their descent to the surface. The Moon they land on will be better understood because of what Artemis II brought back. The risks they face will be more precisely calculated. The habitats being designed for Artemis Base Camp will be built with knowledge that simply did not exist before April 6, 2026. NASA Science Directorate Associate Administrator Nikki Fox said, "Our 4 Artemis II astronauts took humanity on an incredible journey around the Moon and brought back images so exquisite and brimming with science, they will inspire generations to come." But here is what does not appear in the press releases. Here is what the mainstream coverage glosses over in favor of the beautiful photographs and the presidential phone calls and the record-breaking distance numbers. The far side of the Moon is not well understood. We have orbited it with robotic spacecraft. China's Chang'e missions have landed on it. But human observation from nearby space, the kind of nuanced, adaptive, real-time scientific attention that only trained astronaut scientists can provide, had never happened there before. The Artemis II crew spent 7 hours in close proximity to a face of the Moon that has been fundamentally inaccessible to human senses since the beginning of time. 7 hours is not a lot, but compared to 0, which is what we had before, it is everything. Within 6 months, all imagery of the Earth and Moon taken by crew and vehicle cameras, audio recordings of the crew's science observations, and accompanying transcripts will be made publicly available for the broader scientific community. This data will be analyzed by researchers at universities and space agencies around the world for years. The impact flash observations will be cross-referenced with citizen science data from the Impact Flash project. The eclipse imagery will be run through solar physics models. The color-enhanced geological photographs will be compared with orbital spectrometer data from the Lunar Reconnaissance Orbiter. Layer by layer, the information gathered in those 7 hours behind the Moon will be unpacked and processed and built upon until it becomes the foundation of knowledge that sends human beings back to the surface. Think about what that means for the people who will actually land. They will descend to a world that has been seen, photographed, and directly observed by their predecessors. They will know where the meteoroid impacts are most frequent. They will know the mineral composition of the terrain. They will know how the sun's corona behaves from that altitude. They will know where the magnetic anomalies create unusual readings. They will carry with them the experience of 4 people who went there first and came back with the most comprehensive human-gathered lunar data set since the last Apollo mission walked away from the Moon in December 1972. That is the real weight of what Artemis II accomplished. Not the record-breaking distance, not the stunning photographs, not the presidential phone call. The real weight is in what it built, in the knowledge infrastructure, the validated technology, the confirmed human capability in deep space for everything that comes next. Commander Reed Wiseman told the world in a communication from behind the Moon that when the crew could see Mars in the darkness of the eclipse, all of them commented on how excited they were to watch this nation and this planet become a two-planet species. A two-planet species. We are not there yet, not by a long distance, but we are closer than we have ever been. And the thing that moved us closer was not a robot, not an algorithm, not an autonomous system. It was 4 human beings in a capsule called Integrity, disappearing behind the Moon for 40 minutes, seeing things no camera could catch, and coming home to tell us what they found. The far side of the Moon is no longer completely hidden. Not anymore. But here's the question nobody's asking yet, the one that will define the next decade of space exploration. If 7 hours of human observation on the near approach to the far side revealed this much, the impact flashes, the corona mysteries, the geological detail, the magnetic anomalies, the eclipse phenomena that exceeded scientific expectation, what will we find when human beings actually land there? What is waiting on the surface of the Moon's hidden hemisphere that 40 minutes of silence and a handful of witnessed flashes in the darkness only barely hinted at? The answer is out there, 252,000 miles away, on the dark side of a world we have been looking at every night for our entire existence, seeing only half of it, and believing that was enough. It was never enough. It is still not enough. And the mission to find out what is truly hidden in that darkness has only just begun.